Today we are going to be continuing to talk about polynomials, specifically multiplying polynomials. This is a skill that's going to be really important moving forward. We've done this on a smaller scale before, but we need to kind of ramp it up to full polynomials and kind of how we work through this. So we're going to start with just a very kind of basic introduction to how we multiply these. So when we are multiplying anything that has exponents and numbers out front together, we always take the coefficients, so those numbers out front, and those are actually multiplied. So we multiply the coefficients, and then we add the exponents. Okay? And that goes back to our exponent rules that if I'm multiplying the bases, we add the exponents. That's why I'm adding here. So what that's going to look like, if I give you an example here of 3x squared times 4x to the fifth, the 3 and the 4 need to get multiplied, and the 2 and the 5 need to get added, and then the x just comes across. So what I'm really going to do here is I'm going to take the 3 and the 4 and multiply them. That gets multiplied on front of the x. And then in the exponent here, I'm going to add the 2 and the 5. Now, this is a very kind of long written out way. You don't need to show this work every time, but I just want to make sure it's clear of where I'm going to get the pieces in this next step. So I would do the 3 times the 4, which is 12, then the x, and then 2 plus the 5 gives me 7. Okay, so when I take 3x squared and multiply it by 4x to the fifth, the 3 and the 4 give me a 12, the 2 and the 5 I add to give me a 7. So that's going to be the general process of what we're working with, but we need to kind of bring it up to bigger polynomials. So we're going to start with binomials of various degrees, and then we'll start to get into trinomials and eventually into things that are bigger than trinomials even. Not so much in the notes today, but we could if we needed to. So let's talk about two ways that we can do this. These are two methods. Both of them are perfectly valid. It is absolutely your choice which one you use. I tend to go towards one because I think it makes a little more sense conceptually, and I think most people tend to use that one. So we'll talk about which one that is as we get going here. But if that doesn't make sense and you want to do it with the other one, that is absolutely fine. I want to make that clear that both of these methods work for anything. It is completely your choice which one you do. Okay, so let's start with the first one here. The first one is what we call distribution. In general, that's what it's referred to, but we actually know it by another name. You already know this one. It's what we refer to as FOIL. So first, outside, inside, last. That's specifically when we have two terms times two terms, or two binomials being multiplied together. What we're going to talk about is how do we extend that to kind of then go to, well, what if one of them is a trinomial, or what if they're both trinomials? How do we work with those? So really what we're going to do is we're going to take the first term and we multiply it by each term of the second polynomial. So I'm going to take the 2x, it gets multiplied by 4x squared and by the 1. When I do that, 2x times 4x squared gives me an 8 and then an x to the third. Okay, again, multiplying the 2 and the 4 and adding, there's a 1 here on the x to the x squared. Then I multiply 2x by the 1, which gives me a 2x. Now we do the same thing with the negative 3. So negative 3 gets multiplied by 4x squared and by the 1. Well, negative 3 times 4x squared is negative 12x squared. And negative 3 times 1 is negative 3. And now I technically have all of my pieces, but I do want you to write all of your answers in standard form as much as we possibly can, which means I'm going to put the squared term before the x term. So I'm going to switch these two middle terms. So my answer here is going to be 8x to the third. Minus 12x squared plus 2x minus 3. Okay, and that's my answer. That's all we're going to be doing. Again, we're going to be building up to larger problems, but that's the basic idea of what we're doing. And now let's talk about the other method. The other method is what we refer to as the box method. Okay, you could also call it an area model if you wanted to. So the way this one works is I start with a box of sorts. You can make it as big or as small as you want, as long as you can fit all your pieces in it. And what we're going to do is we're going to take and we're going to split this box into, in this case, 2 by 2. And the reason I know it's 2 by 2 is I have two terms in the first. I'm going to put that down the side, minus 3. And then two terms in the second one as well. Those are going to go across the top. Now, if one of those had 3 terms, then I would add on another row or another column, depending on where it's at, to continue my box. So this one's technically a square. It doesn't need to be a square. It could be a rectangle. If I had 3 terms up top, I would add in another column there, and I would multiply. Okay, now the nice thing with the box is it helps us stay organized as we go. So I'm going to multiply the same pieces together, but I'm going to get those pieces in kind of an organized way. So I'm going to start by multiplying whatever is above and to the left of each box and get whatever goes inside of it. So 2x times 4x squared is going to go in this first box. That is my 8x to the third. Then you can either go down or across. I tend to go down. So I do negative 3 times 4x squared, which is negative 12x squared. Then I'll go across to the second column. 2x times 1 is a 2x. And negative 3 times 1 is negative 3. Now I have all my pieces, and when I bring it out to write my answer, I'm just going to put them in order based on their power. So I have an 8x to the third, then I have a minus 12x squared, then a plus 2x, and a minus 3. Get the exact same answer, which should happen because I started with the same problem. I don't think I said that, but these are the same problem. Exact same thing. You can either do it with the box or with your foiling or distribution. Okay. One thing I do want to point out as well, if I did have any terms where the powers were the same, so if this was a negative 12x squared and the 2x was also squared, I would need to combine those like terms together. So it is one thing I'm looking for here is as well as like terms. This one didn't have any, but we'll have to keep an eye out for that as we continue. Okay. So we're just going to work through 4 more examples of just doing this. I'm going to start with this first one here. I'm going to do distributing again, and then we'll kind of go from there. So, for this one, I'm going to start with the x squared. X squared gets multiplied by 2x to the third. That gives me 2x to the fifth. Then I take the x squared, and I multiply it by the negative 4x. That gives me negative 4x to the third. Then I take the 3x, and I multiply it by 2x to the third. That gives me a positive 6x to the fourth. And again, for all of these, I'm following the same rule of multiplying my numbers out front and adding my exponents. Okay. Next is my 3x times negative 4x, which is negative 12x squared. Then I'm going to go ahead and do negative 1 times negative 4x, which is positive 4x. I'm sorry here. I got out of order. Okay, and this is why you want to make sure you draw your things in as well. Negative 1 times 2x to the third gives me a negative 2x to the third. And negative 1 times negative 4x is a positive 4x. Okay, now I got everything. Okay, now I need to look here to make sure I don't have any like terms. So starting with my fifth power, that's going to be my first thing. I don't have any others of those, so I can go ahead and bring that down. Then my next power is going to be 4. I only have one of those, so we'll bring down the 6x to the fourth. But when I get to the thirds, I have a negative 4x to the third, and I have a negative 2x to the third. So now I want to combine those together. Now I just simply adding the numbers out front together. So a negative 4 plus a negative 2 gives me a negative 6x to the third. You can think of it as, ignore the negatives for a second. I have 4 things and 2 things. Gives me a total of 6 things. I'm just adding those things together. For squareds, I only have the negative 12x. So negative 12x squared. And the last one I haven't used is the 4x. So a plus 4x. Okay, and that is my answer for number 1. Okay, so that one you can see I did have some like terms. Sometimes you'll have lots of like terms, sometimes you won't have any. You just got to be careful and look out for those. Okay, the nice thing you can do is when you're putting these in order, if you're going in standard form, if you have like terms, they should end up next to each other. So if you miss combining them, you end up with 2x to the thirds here, and you should see those. So just a quick check on that as well. Okay, let's go ahead and move on to number 2. Since we just did distributing, let's go ahead and do the box on this one. So this box is going to be a little bit bigger. I have 3 terms in my first polynomial and 3 terms in my second. So this needs to be a full 3 by 3 box, and I'm going to give myself enough space here to draw those in. Okay. The thing with the box as well is it keeps us organized. It also tells us how many terms we should end up with before we start to combine things together. So I have 9 squares in this box here. That means I should have 9 terms before I start combining together. Okay, let's go ahead and write in our first polynomial. I always put the first polynomial down the side. You could put it across the top. It doesn't matter which way you actually put it. The biggest thing is just making sure you're multiplying correct pieces together. Okay, I'm going to actually switch to a different color here. Okay, if we go ahead and do this, I have 3y to the third times y squared. That's just adding my 2 and my 3, which gives me a 5. So this is going to be 3y to the fifth. If I keep going down, I'm going to have y squared times 3y squared, which is 3y to the fourth. and y squared times a negative 2y is negative 2y to the third. Then we keep going. Negative 4y times 3y to the third is negative 12y to the fourth. 3y squared times negative 4y is negative 12y to the third. Negative 2y times negative 4 is a positive 8y squared. Go again, last column here. 5 times 3y to the third is 15y to the third. 3y squared times 5 is 15y squared. And 5 times negative 2y is negative 10y. Now, this is where I'm going to reveal that this is the way I actually like to do these, because this actually organized my terms for me. Okay, if you look at your powers here, 3y to the fifth, I don't have any that go with it. But here I have my y to the fourths. They're right next to each other. Same thing with my thirds. There's 3 of them actually, but they're all in that nice diagonal. Same thing with your y squareds. Okay, now, with the boxes, that's not always going to happen. Okay, because we know we don't always get like terms. But if you have like terms and you set it up in the box, more than likely they're going to be by each other like that, which makes it a little bit easier, a little more organized to work with. So let's go ahead and combine these together and pull this out for my final answer. We're going to start with 3y to the fifth. Again, that one's by itself. My y to the fourth, I have a 3 and a negative 12. If I add those, I get a negative 9. So I have a negative 9y to the fourth. For 3, I get 3 of them here. So negative 2 and negative 12 is a negative 14. But then I have a positive 15. So this is just going to be positive 1y to the third. Just the 1 is optional. If you don't want to put the 1 there, that's fine. Then I have 15 and 8. Both are positive. So we'll add those together, which gives me 23y squared. And finally, my negative 10y, again, doesn't have a pair or anything to go with it. So that is my answer. So again, I like the box method better. I think it keeps you a little more organized. Helps you kind of keep track of what you're multiplying. You saw a little bit when I was doing the distributing on the first one here. That actually missed a term. I missed that middle one because I was just kind of going too fast, which is really easy to do. That's really hard to do when you have the box because that would be an empty square. You still definitely have to know you're multiplying, but the organization of it I think definitely helps. So, that being said, I'm going to stick to boxes from here on out. But again, if you want to go back to distributing because you feel like that makes more sense, that is completely up to you. Alright, next one here. Have my box. Number 3, I have 2 terms and 2 terms. So, this is just going to be a 2 by 2. Now, this one is a little bit different because now I have 2 letters, or 2 variables that I'm working with in each one. I have p's and r's. So, it's still going to work the same way. That I'm going to write in my terms as I have them right now. Across the top, I'll have 8pr to the fifth and 6p to the third p squared. Real quick here, just on this 8 term, p has a power of 1, r has the power of 5. It's important to know what exponents are going to which letters there. Okay, now, when we start to multiply, we're going to follow our same rule of we multiply the coefficients and add the exponents. When you are adding exponents, you can only add exponents if they're on the same variable. So I cannot add my 3 to my 1 here because this one's on p and this one's on r. I can, however, add the 3 to the 5. So what's going to happen is I'll multiply the 8 and the 4, which is 32. The p has nothing to go with, so it's going to stay just as a p, or a p to the first. But my r's, I add the 3 and the 5, and I get an r to the 8th. If I move down to the next one, 8 times the negative 3 is negative 24. Now I have a p to work with, so I add the 2 to the 1, which gives me 3. And the r, I add 2 to 5, which is r to the 7th. Then we move to the next one. 6 times 4 is going to be 24. P to the third has nothing to go with, so that will just come down. R to the third, and sorry, this is an R to the second. R to the second and R to the third is R to the fifth. And then finally, 6 times the negative 3 is negative 18. P to the second, P to the third gives me P to the fifth. R to the second is R to the fourth. Alright, now I need to look for some like terms. So let's be very careful about what we mean by like terms. Like terms means I have all of the same variables and all of the same exponents. So I want you to pay attention to my 2 kind of 24 terms I have here, the bottom left and the top right. In these two boxes, I have a p to the third. However, my r's are to different exponents, which means I am not allowed to combine these together. So I have to keep them separate. Okay? It is completely up to you as far as the order you put these in. Because I have two different letters, we do not have standard form anymore. Standard form only applies if I have one variable happening. So if I start to just write these out, I'll start with the 32. P and r to the 8th. I'll just come down to the negative 24, p to the 3rd, r to the 7th. Then I'll do my 24, p to the 3rd, r to the 5th. And finally, negative 18, p to the 5th, r to the 4th. So I just kind of went in the order that I did them, top, then bottom, top, then bottom. If you want to go across, that's fine. As long as you have these 4 pieces, your answer will be correct. Okay? I'm going to be moving on to the 4th example here. I do challenge you real quick just to pause the video and try number 4 on your own before I go through it. I'll go through it here right now and show you how to do it, but give yourself a little bit of a challenge, see if you can do it on your own, and then check your answer with mine. So let's go ahead and draw our box here. I have 2 terms by 3 terms. So I'm going to make a 2 by 3 box, so kind of an oblong here. Looks like that. Down the side here, I have 7ab and 5a squared b. Across the top, I have 6a to the 3rd, b to the 2nd, negative a squared and b, and 2b to the 3rd. All right, let's go ahead and start multiplying. I have 7 times 6 is a 42. I have an a with an a to the 3rd, gives me an a to the 4th, and a b with a b squared gives me b to the 3rd. Then we move to the next one. I have 6 times 5 is 30. A squared and a to the 3rd is a to the 5th. B and b squared is b to the 3rd. Continuing on to the next one, 7 times a negative. There's really a 1 here if you want to think of it that way. So it's going to be a negative 7. I have an a and an a squared gives me an a to the 3rd. B and b gives me a b squared. Next one, 5 times a negative 1 is negative 5. A squared times a squared is a to the 4th. B times b is b to the 2nd. Excuse me, last 2 here. 7 times 2 is 14. A has nothing, so it's just going to come across. B times b to the 3rd is b to the 4th. Next one, I have 5 times 2, which is 10. A squared just comes over, and then again I have a b to the 4th. All right, quickly looking through these. It looks like I do not have any like terms. My b's do match quite often, but the a's are always different. So I need to have both the a's and the b's match in order to have like terms. So I'm going to go ahead and just start pulling the pieces out of this. So this is going to be 42, a to the 4th, b to the 3rd, plus a 30, a to the 5th, b to the 3rd, minus 7, a to the 3rd, b to the 2nd, minus 5, a to the 4th, b to the 2nd, plus a 14, ab to the 4th, plus a 10, a squared, b to the 4th. And that is my answer there. Okay, so just a quick recap of our video here. We are multiplying polynomials together, which means we are always multiplying the coefficients and adding the exponents. You have 2 methods to do that, either foiling or distributing, and the box method, or what you could call an area model. Either one is fine. Okay, again, the box method does keep you a little bit more organized, but if you feel like you can do it with distributing, that is up to you as well. You do need to make sure you're showing all of your work for these. Make sure you're combining those like terms and putting your answers in standard form. If you have any questions, let me know, and we'll try and get those taken care of.